Give me a better angle. I mean, 45 is good and all, but it's too easy. Yeah. What? 60. We okay with 60 degrees?
Yeah.
Okay. Still want to go radius of 2?
Yeah.
Okay. So a radius of 2 with an angle of 60 degrees would put me right there at 2, 60 degrees, or 2, pi over 3. Okay? You already have one, don't you? Or were you not here the other day?
I wasn't here.
Okay. All right. Yeah. Yeah. Don't take if you already have. Just because you forgot, take notes on your own, because we only make enough copies for everybody. So, just so you know. Okay. So there is that point plotted. Okay. Now let's come up with the 3 other names for them. So we've already got the positive. Yes. Okay. What else do you want to do? What would another way to be to name that exact point? Do we agree with -2, 240 degrees? Yes or no? Yeah? Yay or nay, son?
I don't know.
Yes or no? Agree with that? Yes, Paul? Okay, I would concur with that. Would you also agree with -2, 4 pi over 3? If we were in the radian form of it? Okay, love it. And that's 1. Need 2 more. Positive did. Negative did. Next one. Did you hear the hum? Heard the hum. It was annoying. Other one. We got 2 more to do. What do you got, Jordan? +2 or -2? -2. That one? Last one. Oops, excuse me, that should have been negative. Speak now or forever hold your peace. Awesome, we all know that. Good, we don't have to spend more time on that. Love it. All right, so next, I want to talk about the difference between rectangular points and polar points. if I have a point that's out here, okay, in rectangular speak, that is the point x, comma, y, which means I go a certain amount to the x direction, and I go a certain amount to the y direction. That's rectangularness there. Okay? Polar tells me that I can just go directly to it with an r value and a theta value. Okay? So then this point out here would be r, comma, theta. I want to know how to convert between x, comma, y, rectangular form, and r, comma, theta form. How are we going to do that?
X squared plus y squared equals r squared.
Okay, because what's that?
Pythagorean theorem.
Pythagorean theorem. So r would be what?
The square root of x squared plus y squared.
Okay, love it. So if I have the x and the y of my point in rectangular, I can square both of them and then add them together and take the square root. Okay? That's 1/2 of what I need to get from rectangular into polar. Oops, I should put it like this. I'll do that afterwards. Okay? What else do I need? That gets me r of r comma theta. What else do I need? Okay, but what does the inverse tangent give me? So first caveat is we drop negative signs. I better just write that out so we don't forget what that is. And then the second thing is that gives us a reference angle. So when we're dealing with a reference angle in quadrant number 1, my reference angle is what? Is my angle. So theta equals theta prime. In quadrant 2, theta is equal to what? Quadrant 2, theta is equal to what? Oops, sorry, I put theta prime. Theta is equal to what in quadrant number 2? 180 minus my reference angle. I feel like we've done these before. In quadrant number 3, theta is equal to what? 180 plus the reference angle. And in quadrant number 4, theta is equal to what? Bless you. 360 minus my reference angle. Or if I'm dealing with, radians, then it would be In quadrant number 2, it would be pi minus my reference angle. In quadrant number 3, it would be pi plus my reference angle. In quadrant number 4, it would be 2 pi minus my reference angle. Okay? All right? So that is how we go rectangular into polar. How can I go polar into rectangular? What would X be and what would Y be? Shante? Love it. Where'd you come up with that? It's a circular function, right? So think of unit circle, right? Okay. X here is my radius, which just happens to be 1, times the cosine of theta. Okay, what's Y then? Y sine of theta. Or R sine of theta, excuse me. Reminds me of vector math, right? Vectors, all the time. Okay? Love it. So, what I want to do now is I want to change the points to the other form. So 1, you've got to recognize what form you are in. Okay? You got to recognize what form you're in. 2, we need to put that stuff away. Okay? 3, we need to give exact answers if we can. Okay? If it's a unit circle angle, we expect exact answers. Okay? Shouldn't even have to tell you at this point in time that if it's a unit circle angle, we expect exact answers. Okay? All right. So, looking at letter A, is that in polar form or is that in rectangular form? What? Polar. Why is it in polar form, Morgan? How do you know that it's an angle measure? It's because you see a pi, right? Okay. So for 1, you see a pi. What if it were in degrees? How would I know that it's a polar one if the angle was given in degrees? What? The degree symbol. Yep, exactly. Okay. So if you see pi or if you see a degree symbol, that is polar form. Okay? All right? So in this one, I want to go from polar into rectangular. Okay? So polar to rectangular again was, what do I do? So what do I do? Okay. So what do I do? So x, is that x or is that y? X. So x is what you say? What is the cosine at pi over 2? 0? Do we agree? Okay. So this is 3 times 0, which is 0. Okay. Then what? Y is 3 sine pi over 2, What is the sign at pi over 2? So that is 3. So what is my rectangular point here? 0, 3 is my rectangular point. Okay. 0, 3. What about C? What are you thinking, Wolfie? Rectangular to polar, because I don't see a pi or a degree symbol, or like in place of that degree symbol, a little r that would signify radians. Yep. So this is going to be polar, rectangular into polar. Okay. So what do I need to do to go from rectangular into polar? Okay, so r is going to equal the square root of 3 squared plus 1 squared. Square root of 3 squared, anybody? 3. 1 squared? 1. 3 plus 1? 4. Square root of 4? 2. Okay. That gets me r. Now what? Inverse tangent of? You tell me which one. She gave me both. Which one is it? What you got? She gave me both. She gave me 1 over the square root of 3 and the square root of 3 over 1. Because it's y over x, right? Okay. So it's 1 over the square root of 3. 1 over the square root of 3. Inverse tangent of it. Talk to me. Man, what should we probably have out? Agree with pi over 6? Agree with pi over 6. Okay? So that gives me a reference angle of pi over 6. Which quadrant am I in? KB? 1, because it's positive, positive, right? So theta prime is my angle, correct? Because I'm in quadrant number 1. So the polar coordinates here would be 2, pi over 6. Would be my polar coordinate for that rectangular point. Yes'm? Yes'm. What I would like you to do now is I would like you to do B and D. B and D. 3 pi over 6, is that a rectangular into polar or a polar into rectangular? Polar to rectangular, because it's got an angle to go along with it. Okay, so then that would be x equals 3 cosine of pi over 6, and y equals 3 sine of pi over 6. Cosine at pi over 6. Square root 3 over 2. So this is going to be 3 times the square root of 3 over 2, which is 3 square roots of 3 over 2. Sine at pi over 6. What? A half, 1/2. So that's going to be 3 times 1/2, which is 3/2. So my rectangular point would be the point 3 square roots of 3 over 2, comma, 3/2. Agree? Okay. Definitely, and don't want to change that over into a decimal form. Okay. Part D here. Rectangular to polar or polar to rectangular? Rectangular to polar. R is going to equal -2 squared plus 2 squared, and then take the square root of that. That's going to be 4 plus 4, which is 8. Square root of 8 is 2 square roots of 2. Theta prime, my reference angle, would be the inverse tangent of 2 divided by 2. So that's the inverse tangent of 1, which is how many degrees or radians? I don't care which one. Pi over 4 or 45 degrees. Bless you. Okay. Which quadrant am I in? Quadrant 1. So in quadrant number 1, what do the points look like, Paul? In quadrant number 1, all the points look like a certain, they have a positive, right? I see a negative sign. So we're not in quadrant number 1. What? There's a negative sign right here. So we're not in quadrant number 1. Which quadrant are we in, Alyssa? Dos. We are in quadrant numero dos. So we are in quadrant number 2. So that means what is my theta? So we have to take 180 and do what with it? Subtract 45 degrees, or we have to take pi, because I want to switch pi instead of just 180, and minus pi over 4. So that would give me, in degree mode, that would give me 135. So my point would be 2 square roots of 2, comma 135 degrees. Or, I suppose we can just bring it back up now that everybody can see it, because we'll do those two in a minute here. Or it would be 2 square roots of 2, comma 3 pi over 4. Questiones. Awesome sauce. Do E and F now. E and F now. Am I on the unit circle? So that means then I don't need to be exact anymore because I'm not on the unit circle. So this is a polar into a rectangular one. So x here is going to equal -2 cosine of 5 pi over 8. And y is going to equal -2 times the sine of 5 pi over 8. Right? So I type it into my calculator. Oops, I go like this first. So I type it into my calculator. -2 trig cosine of 5 pi over 8. Now, if I'm using a graphing calculator, an Inspire, or if I'm using a scientific calculator, I should get the same answer, correct? Okay. What do we get here for the x value of my answer? I got 0.765. Yes? Sam, why didn't you get that?
I got -1.99.
Oh, man, how did you come up with -1.99? It's got nothing to do with the hood. Because what? He's in degrees. 5 pi over 8 is what? Is radians. Okay? So you gotta watch your mode on your calculator. Okay? Right? So there's a couple of different ways around it. One, convert it into degrees if you want to be in degrees. Or switch your calculator to radians if you're going to be in radians. Okay? That's an individual call for you. And then my other one would be -2 sine of, again, 5 pi divided by 8. And I get -1.84. We'll call it 8. So again, this becomes the point 0.765 and -1.84. Okay. -3, -5. Again, that one is, so now this is rectangular. And we want to go into polar. Okay. So R here is going to be -3 squared plus -5 squared. And then I take the square root of that. So that's going to be 9 plus 25, which is the square root of 34. Okay. Can that radical be simplified? No, so we're going to keep it that. Okay. Theta prime here now, we're going to find the inverse tangent of what? 5 over 3. So I'm going to go here, and I'm going to go inverse tangent of 5 divided by 3, and I get ruh-roh. Is that my angle? I'm in radians. So that is my radian measure. If I want to convert that into degrees, I have to multiply by 180 and divide by pi, which gives me 59.036. Which quadrant am I in? I'm in quadrant number 3. So that means what? Oops. So what do? Add 180 to it. So theta is going to be what? 239.036 degrees. So my polar point here then would be the square root of 34, comma 239.036 degrees. Okay? Mind your mode. Okay? Watch your mode. Okay? Rectangular equations. Okay, so now we're talking rectangular equations. Those would be y equals something, and that something is going to be in terms of x. Okay? So it's going to be some function based off of x. When you go to graph that, you're going to plot points in x, comma, y form. An equation in polar form is going to be r equals something, and that something is going to be in terms of theta. And when you go and plot something, you're going to plot r, comma, theta. Okay. Just like converting x and y, or converting rectangular to polar and polar to rectangular, we can convert equations into the other one. So on this particular one, I would like to convert, so change y equals 4 into a polar equation. What kind of a graph is the rectangular graph y equals 4? What kind of a picture does that produce? What was that? Horizontal line. How far up off the x-axis? 4 up off the x-axis. So 1, 2, 3, and 4 would be right here. A nice horizontal line that looks like that. Okay? All right. So what we need to do is we need to convert y equals 4 into a polar equation, which will then allow us to graph it. Let me move this over a little bit. Hopefully this is movable. Oh, look at that. It is. So this was rectangular y equals 4. Now, going back to your toolbox, which you probably have on some page in your purple packet, what can I put in place of y when I'm converting it? Because I can't really do much with 4, but I maybe can find something that y is equal to out there. Anybody got anything? Any ideas? Y equals anything? Y is equal to r sine of theta. So r sine of theta is equal to 4. Polar equations are R equals. So what would I need to do in order to solve this?
Divide by the sine of theta.
Divide by sine of theta. So I get R equals 4 divided by the sine of theta. Can I make that look pretty? Can I make that look pretty? R equals 4 cosecant of theta? Yes? On the graph, 1, 2, 3, and 4, it will look like that. Okay. If I made a graph here, page of a graph, if I entry and edit, and I want to go into polar, tab, I go R equals, whoop, tap the brakes, going over here now. If I go R equals 4 cosecant of theta, there it is. Okay? Straight across, just like normal. Okay?